Let's start our discussion with relative motion of two particles. Consider two automobiles A and B moving along the same road. Now let's say automobile A has XA as its position coordinates and B has XB as its position coordinates measured from the origin. The difference XB minus XA defines the relative position coordinates of B with respect to A. It is denoted like this. Here, the position coordinate of B with respect to A is positive if automobile B is to the right of automobile A, and it is negative when B is to the left of A. The rate of change of distance is velocity. Hence, by differentiating the equation, we get the relative velocity of B with respect to A, and it is denoted like this. The rate of change of velocity is acceleration. Hence, by differentiating the relative velocity of B with respect to A, we get the relative acceleration of B with respect to A. It is denoted like this. Now let's see something interesting. Observe that two buses P and Q are traveling along a highway from place A to place B. They are moving with the velocity of V1 and V2 respectively. Another bus, say R, is traveling from place B to place A along the same road with a velocity V3. An observer is observing the buses from a hotel along the highway. Thus, the velocities V1 and V2 are considered to be positive and V3 as negative. Now, if the observer is traveling in bus P that is having velocity V1, then the relative velocity of Q with respect to P will be V2 minus V1. Similarly, relative velocity of R with respect to P will be minus V3 minus V1. That is minus of V3 plus V1. So, when the buses travel in opposite direction and collide with each other, the damage is more. So friends, in this session, we studied the relative motion, relative velocity, and an example based on relative velocity.